look at functional programming and Scala today in very detail. First you understand the concepts. Again, this is the first time I am attempting this in any batch. I had done a very good study of these things in order to, even though I knew the concept, how to make it very clear to a normal programmer on what exactly is the difference between functional programming and the normal way that you do programming. I've given you a small overview that any functional programming language should have idempotent property, right? It should be easy to test. It should exhibit referential transparency, right? And it should be memoizable. We should be easy to parallelize the artifacts of functional programming, and it should support lazy evaluation. These are 6 highly technical terms which is guiding or which is driving the principles of functional programming, and today we will see what each things mean. I will share you this complete thing, but first you understand clearly. So I'm going to share a folder today at the end of this session, and that's called fpfundas.tar, which I will upload and I will give you. And what we will do is we will look at the functional language or functional programming properties, okay? And all the properties inside the tar file are classified into different directories. You can see almost an equal one-to-one mapping with some extra directories in that, which is illustrating you each concept what we are going to learn in functional programming. One thing is sure, that I like Java very much, but I hate Java when I compare with Scala, because once you get into the beauty of that language, and it is not easy to learn, let me tell you, okay? And once you get it right, what is meant by currying in Scala, what is meant by higher order functions in Scala, etc., then you will start enjoying the power of this language, and you will not look at any structured or object-oriented programming language unless it is so important to you once you understand this, okay? That's the beauty, because it has been created from years of expertise the people have gathered by working on different languages. And I told you about Martin Odersky, right? He was part of JVM, he was part of generics, he was part of many innovations. He worked with Nicholas Wirth, the creator of Pascal, right? And he's the one who created that particular language. And the framework built on the top of Scala called akka, which is the concurrency model or the actor model for Scala, that is the main thing behind the usage of Spark, behind the creation of Kafka, etc. So it's very powerful, okay? First of all, out of all these things, there is no mention about the word called mutability. So first you should understand what is this. I gave you a very high level glimpse of what is mutability by introducing you to the word val, right? Val, if you create in Scala, that means you won't be able to change it unless you create a new val, right? Whereas var, if you use in Scala, you can change it like a variable. This is not advisable. This is what you should be using always, right? But what is the need of all these kind of things? So let us just look at one of these things. Every folder, in order to make you remember at a later point of time, there are some classes, and then you can just run the classes, and then you can see and you can understand it. First, let's start with a person class, and I have got vi person.java, right? A simple person class which is represented in Java. I am using little bit of Java, little bit of Groovy, a new language, and little bit of Scala in order to introduce you all these properties. So class person has got two attributes. One is the name and another is age. And it has got a constructor. A constructor is the functions in a class which are having the same name as that of a class, and it is internally used for creating instances of the classes. In object-oriented programming, there is a word class which is encapsulating all your attributes, as I told you about the remote controls and all those kind of things. And you will use objects which are the instances of the classes, and to create an object, the underlying platform needs the definition of a class and a special function called a constructor. A constructor is having the same name as that of the class, always. Okay, that's why you will see the function called person. Another important property, a constructor will never return anything, unlike normal functions. So you can see the constructor is not public void person or public string person. It is public person, which means that it will not return anything. The reason is that it is not being used normally to call a particular function or something like that. It is internally used for creating an instance, right? If you go very close to object-oriented programming, you can even see that a class is also an object. A class is actually created by another class called a metaclass. A metaclass creates a class, and a class is used for creating an object. That's how object-oriented programming is providing. There are languages which is allowing you to edit a metaclass. Smalltalk is an example. Java does not allow you to edit a metaclass where you can control the creation of a particular class. And another important property of a constructor is that a constructor can have the variables which is used for initializing. For example, when I pass a name and age from the outside world, it will take that name and age, will assign it to that internal variables of this particular class. So every constructor will be normally have the parameters equal to the number of attributes. It is not necessary. Normally, that's the way. Why? Because when you are creating an object, you want to initialize all the values within that particular thing. And there is another very important property in Java, C++ and all called static functions. What is meant by the word static? So you should understand clearly between class and object in order to understand what is static. If you declare a variable or anything as static, that variable or function does service to the class. It is a class service. If you define a function which is not static, it does service to object. That's the difference. Static functions are for classes, whereas instance functions are for objects. Okay? Whenever you declare a static function, that function, since it is belonging to a class, it is shared by every object that you are creating. For example, assume that I represent every one of you as a person, and assume that I got the age of every person, and I want to write something to add all of your ages together. Then I need that variable to be shared. Why? Because I have to declare a variable total equal to 0, and then I will add Bala's age, Shalva's age, Udaya's age, everything into that. So that variable should be shared across all the objects. That's where the word static comes in. So static is used for sharing across all the different classes, whereas non-static, a normal variable without the word static, means that it belongs to object. always. Now there is a very interesting problem or property that object-oriented programming exhibits. A constructor is used for creating an object. So a constructor actually is doing an object service, not a class service. However, if I declare a variable static on the top as static total equal to 0, and then if I write the total inside, that is allowed, which means that a constructor can do static service for class as well as instance service for the object. The only functions in object-oriented programming which can do class service and instance service at the same time are called constructors. So if somebody is looking at a definition of the constructor, the world's best definition of a constructor is one which can do class service and instance service at the same time. Now, whenever you create a class, it is inferred that every class will have a get function which are called as accessors and a set function which are called as mutators. Mutators and accessors. Every class will have it normally for retrieving the data. It is not again necessary, but it's a good practice to have accessors and mutators. Accessors will allow you to get the value. Mutators will allow you to assign the value. Set name is a mutator which will set the name. Get name is an accessor which will get the name. Accessors and mutators. And now if you look at Scala, if you want to create a class person with name and age, you will write case class person, and inside that you are going to write your variable is going to be name colon string, and the next variable is going to be age colon int. That's all. One line in Scala will create the entire class, entire constructor, entire accessors, entire mutators for you. You don't have to write anything in Scala other than this line. They have given you one line facility which you accomplish in a programming language by writing that many lines by creating it. So you are going to see this line a lot in the Spark programs and in the Scala programs where you are creating it. And of course, you can add your own functions below that so that the class will now contain all the default functions plus the additional functions that are available on Scala. Okay. Now, comes to mutability, right? This is the class person, and I wrote a getAge function, and I intentionally wrote a thread here, okay? That is, I will explain to you a little bit later. Whenever I am calling getAge function, I am telling that, okay, don't give me immediately, just sleep for 1 second. 1000 means 1000 milliseconds. Thread.sleep takes a parameter which is the milliseconds, so it is sleeping for 1 second, and then it is returning an integer value, okay? Nothing much there, but just imagine that when I call a getAge function, immediately it is not returning. I just wanted to create a delay there, okay? And then all the functions are there. Now comes the next program, which is find all the persons total age, which is the next Java program in that particular directory. So let us write a small code there. I'm going to create some persons. So in Java, you can create number of persons. Remember, when you write new person, it will call the constructor that I have just explained to you, and it will create the person. So I'm creating Scott with age 20, King with age 25, Alan 30, Steve 40, Jobs 50. So I created 1, 2, 3, 4, 5 persons, right? And then I created a variable called total age equal to 0. And inside the total age equal to 0, I am going to write, okay, get all the list of friends. What is the name of this particular variable? The list variable is called friends. So get all the variables from friends, which is this. And then remember there was an accessor we have written. So call that getAge method, add to this total age. As I mentioned to you, you declared a variable total age equal to 0, and then you added it, and then you are telling total age of all good friends equal to total age. And look at that comment there, not so good approach. Why it is not so good approach? It is a nice program. It is finding the total age of all friends, and if suppose I do a compilation of the code, find all persons dot java, right? And then if I write java find all persons age and then execute this, I should get the result as the total age equal to 165, but since I mentioned not so good approach in that system.out.println, it is printing you that particular value. And this is where the thoughts behind functional programming starts. So let us look at that program. Do you see any issues? Not normally. Any Java programmer will tell a good program, right? You can declare a static variable and you can add it, but however, that program is executing what is expected, but there are many issues in this particular program, and that's what is being addressed in the functional programming stuff. The first thing, you declared a variable total age equal to 0. Very good. Total age is equal to 0. You declared a variable. Is it int? It is int variable. Is it a val or is it a var? It's a var. There is no concept of a val. But you can declare the variable as final. But here it is a var, which means that anybody can go there and write another line, total age equal to 10. Entirely your program went wrong. The system is not restricting anybody to go there and change that particular value. That is the first problem. So if you come down and then look at the comments that I have written, code suffers from primitive obsession. That's the beautiful word that is used in the industry. I got most of this stuff from an agile developer kind of site. One Mr. Venkat is there, who is worldwide a great speaker, and is very nicely taught. And some of the stuff is from Alvin Alexander, and some from Martin Odersky, and some from Coursera. There is a course called Martin Odersky directly takes a course, Scala. Anybody can join it, it's free.
No, you have to pay $50.
That is for only for certification. So no, it is not
even for studying also.
Oh, okay. So yeah, $50 compared learning a language. Learning a language is obviously much valuable than that, right? Of course. So the code suffers from primitive obsession. We have to convey every detail. We have to get the value from friends, get the age, add the age to a variable, repeat for all. It is our responsibility to get that particular value and iterate through all the variables inside and then get that particular value and then add it. And if you look internally, what the total age is doing in that code, the total age is a temporary garbage variable which is just there for the sake of executing that particular loop to get the result, and then it is gone after it is printed, correct? So it's a garbage variable. Mutability introduces more difficult to reason the code, and we have to manage the order of execution. What happens if the total age equal to 0 is written after your entire result got into problem, right? Order of execution is very important. You should know where you write your initialization variable and where you are going to manipulate it. That is another one. Finally, if that parallelization big data is the new architecture and new paradigm to follow, and if Sam is executing that code and Bipin is executing that code and everybody of you are executing that code in parallel, how the total age is going to behave? Some systems will take 2 of the persons, some systems will take 3 of the persons, and you don't know how that result is going to be. And mutation has got side effects which introduces many bugs. So let us change the code to avoid all these things. The way in which we are going to change is we are going to use the functional style of Java 8. I am going to tell Java that get everything as a stream and then map every person that is coming from that stream to an integer, because get age is returning an integer, stream may be coming as a string data type. You have to map it. In Java advanced streaming examples, that function is called boxed. I will introduce it a little bit later. Here I am not using boxed, but I am using the function called mapint, and then call that get age function and then call sum, which is adding the total. See the beauty there and see the style of programming, how it is different. And this is what you should concentrate. It is not wrong. It is absolutely fantastic to write that total age variable and declare it. But we have gone deep inside the code and we looked at the mutability issue. And we looked at the total age variable issue. We looked at the problems which are lacking while we parallelize it. And we are going to write that particular code. So if you change that, and if you write this one, and if you go through that functional style of programming, you avoided mutability. Now you may ask that internally somebody is doing that total age and all those kind of things. Who is doing that? Some. So it is not that mutability is completely avoided. It is that you as a programmer is avoiding it. Internally system, let system manage it. And if the system is managing it, system knows how to manage it rather than you are introducing it and you are allowing the other programmers to come and change it. Right? So, first one to learn, in functional programming, mutability is forbidden. It is not to be used. Right? Let system do it. Of course, if you look at structural programming introduces three things: sequencing, selection, iteration. These three are the watchwords of structural programming: sequencing, selection, iteration. Great work on done by my college onwards. He is my fan, Dijkstra. Okay, highly powerful mathematicians. One who is living in the world currently is 4 or 5 years back he died. Is Edster Dijkstra. He is a Dutch scientist. He is the one who has done lot of work on Pascal, who has done lot of work on structural programming. He can be called as father of structured programming. And Dijkstra did 2 mistakes in his life, which he reiterated himself at a later point of time. One, he invented null pointers or nulls in programming. Second, he introduced goto in programming. And both were tremendous mistakes in the world of programming. He himself has acknowledged that at a later point of time. So, if suppose you look at Java, goto is a reserved word in Java, but never ever you can use goto. If you write a program and then use goto, you will get wrong results because the JVM does not support goto, even though goto is a reserved word. They kept goto as a reserved word. Why? Because most of the languages are having that in the initial pages. They put, okay, let it be there. If you want, we will use it, but they never used it. Instead, Java uses break and continue to come out of a loop and all those things. So, goto is a big mistake in the world of programming. So, in the Wikipedia, if you search structural programming, avoid go to, Dijkstra, you will get that complete page, what he has written. Why? Go to makes your code spaghetic. What is meant by spaghetic? If you have a code, 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. And if suppose I write a statement called go to 10, it will go directly, the control jumps from this particular place to this particular place. And in between, if you suppose there is an if condition, you write go to 5, it will go from go to 5. And from 5, if you write another go to, it will go to 8. It becomes spaghetic. It is very difficult to control. The control flow statements go haywire. Because of that, go to should not be used in programming. Good. If go to should not be used, for example, I am going to write a nice for loop which is there in Mutability reality. And if you look at that, there is a sample.java. And then if you go to vi sample.java, I have got a for loop. And if I is greater than 5, it is printing system.out.println 5. What's the output of this program? 6, 7, 8, and 9. That's it. Why? It is iterating from 1 to 10. It is a structured programming control flow loop. 1 to 10. And if I is greater than 5, that means 6 onwards. 10 is not included because I didn't put less than or equal to. I just put less than. So 6, 7, 8, and 9 should be the output. So let's compile this particular code. Java C sample.java and then Java sample. Right? 6, 7, 8, and 9. You got the program. And you got the output. Anybody used Java P? Java P is a decompiler for Java. You can compile and you can see the bytecode instructions if you use Java P. And I have written the comment how to use it in the code. Right? So what I am going to do is I am going to write Java P and you should give an option called -c and you give your class. Any go to? Yes or no? So what do you understand from that? Internally, the system is using go to. That's okay. Again, what I mentioned to you, as a programmer, you will not be writing it. Right? So practically, if suppose you are saying mutability is to be completely avoided, don't ever come and ask that, hey, there is some mutability going on, then what to do, right? It is that programmer is not writing it explicitly. So the first lesson in functional programming, as far as possible, avoid usage of vals, usage of assignments, etc. and use high-level functions like what I have shown you about stream.map.sum, that kind of things, as functional style calling functions without going through much control flow statements and without using mutability in your code like total age. Clear? That's about mutability. Now, next important property is idempotent. What's meant by idempotent? Go to that directory and you can see there are 2 Scala scripts. Okay. And from now onwards, we will follow a small practice. The practice that we will follow is that .sc means it's a script, Scala script. And when I write .scala, it is a complete program. So .sc is Scala script. Can we do scripting in Scala? Yes, absolutely. Where will you write scripts in Scala? On the Scala prompt. When you write 1 plus 2, it's a script. When you write println hello world, it's a script. Is there a main? Is there a class? Is there an object that you created? Nothing. You just wrote a small snippet of code. And that snippet of code is getting executed in your REPL. Read, evaluate, print, loop. That's called scripts. A script will not be the main program which contains everything. Does Java support scripts? No, never. Why? Java is not interpreted language. Java is a compiled language. Scala is both interpreted as well as compiled. What's the difference between interpretation and compilation? Compilation happens for the whole code. You need main, you need class, you need the special instructions for the JVM to create the meta class to instance. Whereas when you write a JavaScript, when you write Scala script, you don't know all these things. You can just execute it. Internally, it will create an anonymous class. That's different.
There is a method here.
Yeah.
In Scala.
Yeah. So you can write scripts, and every script we will write that. So let us look at idempotent 1.c. Vi idem 1.c. Yeah.
What the sum method that you're referring? But if you can create your own function there, right?
Yeah, you can.
The sum is a simple thing, but your complex logic you can create, right?
You can create.
But their mutability will be and that function might be.
You can, wherever avoidable. Please don't take it at heart. That's what I want to tell you. Wherever you can avoid. Okay? There are some places where you cannot. At that time, you have to use it. Maximum. Whereas in object-oriented programming, that is not the case. Everywhere you use it. That's the difference. Okay? Avoid wherever maximum possible. The next one is idempotent. There is nothing inside this, right? It is just adding a function, integer a, integer b, and you are adding a plus b. What's the value I am going to get if I write add 10, 20? 30. Again, I am calling add 10, 20. What's the answer? 30. If I go to India and I execute that add 10, 20, what's the answer? 30. I go to Mexico, I go to US, I go to Dubai, I go to Singapore, I execute the function. What's the answer? Add 10, 20, 30. Very good. Function is idempotent. Vi, not idem.sc. Tell me, what is the value? I am calling add function now. Come on, what is the answer? Add. What is the result? You don't know. What is the result if you are executing in Singapore? You don't know. What is the result you are going to get in Dubai? You don't know. Why? There is a function there which is depending on something different. A function is said to be idempotent if that function is giving you the same result again and again, irrespective of which time you called, from where you called, etc., etc., etc. There is a great facility that is going to come because of this. What is that facility? Can you guess what is that facility? Assume that in functional programming, I wrote a very complex line by using my earlier function. Add of 10, 20, dot something, 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 then again add of x, y, and then again add, 40, 50, like this. Since the just-in-time compiler internally knows that this function is giving me the same result irrespective of anywhere, any value, any time, it will replace that with the value everywhere. Whereas the function will find it difficult to replace it with the value. In this case, why? Because at different times the function is giving a different value which is affecting the performance of your code. A function has to be idempotent, and this is the concept of JIT that you asked last time. A JIT compiler always will look internally what I can replace. Input plus 3 multiplied by 2 will be replaced by the JIT compiler as input plus 6. But
only the code, actually the values will come.
The value will come, yeah. Input plus 10, if I write, it cannot be replaced by anything. Input plus 10 is input plus 10 always. It has to evaluate. But input plus 3 into 2, I don't have that extra computation to go and execute 3 multiplied by 2 every time. I will replace it with the value 6. The function in functional programming has to be idempotent. You should be able to replace it. That's the next concept that we need to know. The next one, easy to test. It is very related with idempotency, but you can just see what is the problem if this easy to test is giving you. Okay, let us look at two code here. Okay, one is vi easy.sc. Again, a Scala script. There is a function which says good morning, good afternoon, and good evening, good night. String hours of the day, it is going to take that parameter and it is going to execute that particular code. So if I call greet hello or greet, and I am giving the parameter Bala, and hours of day, let us say I am giving as 10, it is going to give me good morning, Bala. If I call greet Bala, comma 18, it is going to tell good evening. If any other hour, good night. You call that function anywhere, anytime, any place. So I developed this code from Florida Blue, from Citibank, from TCS, from anything you think of. And you send that particular code to your offshore team who is doing the testing. They will test it beautifully, it will work.
But it will not work, right? The time difference will be
Where?
there.
Where is the time difference? We are easy to... Right?
No, from here.
Yeah, great Bala, comma 10. Look at the function parameter.
Right, but 10 here or 10 there.
What are they going to test? Great Bala, comma 10.
Yeah.
Function is taking the parameter. I am coming to you. What you were told is correct. But wait. And now let us change the program. Vi as he guessed. Not ec.se. Now the problem. I took out one parameter. I'm just giving great Bala now. I'm not giving the hour now. Hour is calculated depending upon the time in that region now. And now everything is gone. Is it easy to test? No, it is not easy to test. Why the problem happened? The problem happened why? Because you created a dependency internally. In functional programming, avoid these temporal dependencies. If you do that, then you'll have to manage it internally. So is it a better function, the other one, or this one? This one is the other one is the best function. Then how the other one will be tested? Other one can be tested anywhere, any place, without affecting the clarity or creativity of the code. We faced this problem many times. There is a company where I wanted to create promotions. The company has branches in US and Singapore. And the company fellow will have logged in and created a promotion for 10 a.m. He went and created 10 a.m. The system is in US time on. The promotion has to happen at 10 a.m. in Singapore. Instead of happening at 10 a.m., what happened? 10 p.m. The promotion, the mails went to 10 p.m. It should be easy to test. The next property is referential transparency. Again, it is related with idempotent. This property controls almost all the things. So, if you look at CD, another one also I will show you, vi symbol.js, okay, symbol.js, in the same directory there is one, right? So, let's go to that easy to test, and then vi symbol.js. It's a JavaScript function. And you created a list 1, 2, 3. The factor equal to 2. The double value equal to function return e multiplied by factor. So tell me what is the value? If I run this particular code, I am calling the map function. List.map double value. The function is taken as a parameter. Look at the beauty of the map function there. The map function is now taking double value. Double value is a function. In functional programming, function is a first class citizen. You can pass function to a function, not only values to a function. And when you call that particular function, whatever written inside the double value will be executed for all the elements of the list, which will give you the answer as what? 2, 4 and 6. No doubt, correct? How will you execute this JavaScript? Anybody? How can we execute a JavaScript on the command? 246. You need Node. That's what Node.js is all about. So Node symbol.js. You got 246. No doubt. No problem. Right? ls vi complex.js. Anybody? What is the result of this now? Oh, one line I introduced, and that line created havoc in the code. Look at that factor equal to 0. What will happen? Entirely the result will become. Why? The function is substituted at the time it is used, not at the time it is declared. Tell me, how will you avoid this in Scala? You will introduce one word here. What is that? Instead of var, you will write. That's it. That's why they have given you that. Now you started appreciating the beauty there. To avoid unnecessary problems. Don't ask me a question now that what happens if you write again val something. No. I'm telling about normal program.
But then you can always privatize and then get it everything.
There are ways, but normally that is not the practice, right? If you do that, then you are thinking in terms of functional programming. That is where.
Oh, that abstracted into the.
Abstracted, and then you have created that particular approach and all, and you don't have to do all that difficult things if you have val. All right. So easy to test is the next one, and we will go to referential transparency. And if you look at the referential transparency, it's just nodes. There is nothing there, right? There are two functions, plus 1. See the beauty. What is plus 1 of 5? 6. What is plus 1 of 5? You call from anywhere. It will be always 6. Now come here. Plus g of 5. Come on. Plus g of 5. What is the answer? G is 10, yeah. So plus g of 5. What is the answer? 15. Wait there. What is plus g of 10 now? 25. Because you declared a global variable. There is a dependency here. And now I am coming to that. Plus g of 10, he told that it is, 15 is 25, right? While that execution is happening, this is a global variable, right? What anybody can do. And what will happen now to your function? You created a dependency on the function. Again, a var will help you to avoid that. So, referential transparency, that is to be maintained. The next property, memoizable. This is very, very interesting example. How many of you know recursion? Huh? Ability of a function to
On its own function. Factorial.
do you know that if you search for google.com and you search for the word recursion, anybody tried this? And please look at the result Google is telling. Oh, spelling. I think they changed it. Right, I think they have changed it. Recursion. Yeah, they didn't change it. Tell me, what is the fun that you are seeing? No, yaar. Recursion. Did you mean the recursion? Okay, click on recursion. Did you mean the recursion? Again, click on recursion. What is recursion? Fun. Recursion is the ability of a function to call itself. A beautiful example, that is end factorial of n. End n is if n is less than or equal to 1, return 1, else return n into factorial of n minus 1. That's a factorial function using recursion. Factorial of 5. Is n greater than less than or equal to 1? No. What is factorial of 5? 5 into factorial of 4. What is factorial of 4? 4 into factorial of 3. What is factorial of 3? 3 into factorial of 2. And what is factorial of 2? 2 into factorial of 1. And what is factorial of 1? 1. Now it will pop elements from the stack and it will give you the answer as 120. Right? Fibonacci numbers. School days. What is Fibonacci numbers? 1, 1, 2, 3, 5, 8. 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 5 is 8. So tell me what is the recursive code for finding Fibonacci number of n. Fibonacci of n is equal to Fibonacci of n minus 1 plus Fibonacci of n minus 2. And if n is less than or equal to 1, return 1. The recursive code will have a base statement which is called the stopping recursion statement and will have a recursive statement which will allow you to recurse through. The recursive statement will allow you to recurse through the stack until you reach the stop statement. If there is no statement, no stop statement, the recursion will go infinite. So you got recursion. And now let us go to memoizable function, right? So cd memoizable. And you will see a Fibonacci number code in Groovy language, VI normal Fibonacci code. It's in Groovy language. Alright, define Fibonacci number, Fibonacci of n, if n is less than or equal to 2, that means 1 and 1. Return 1, else Fibonacci of n minus 1 plus Fibonacci of 9, okay? And I am going to calculate the start time and I am going to call the end time and I am finding the difference in order to find out what is the execution time of this particular code. And I am calling Fibonacci of 20. Can you tell me what is happening when you are calling Fibonacci of 20? Fibonacci of 20, it will become Fibonacci of 19 plus Fibonacci of 18. And eternally Fibonacci of 19 will become
17.
Fibonacci of 18 and 17. And Fibonacci of 18 will become 18 and 17 and then it will go. Unimaginable in the brain. That's the beauty of recursion.
The big stack.
It will create a big stack. Yes, very good. Let us go to this particular site which is there in your document. I have written that for you to help. Okay. Online. The Groovy code can be executed here. You can write any code. They will give you a sample. It is like the fiddle. You can write any code that you like. And I am going to copy this particular code. Okay. And let us paste it here. And let us calculate Fibonacci of 35. And then execute it. And allow some time. I don't know whether a stack overflow will happen. Yeah. It got executed. A big number. Internal stacks are created. How much time it took? 2 seconds? Right? The time taken. I have written the code, right? The time taken is 2 seconds. Good. And now let us go to VI memoizable Fibonacci. I will explain you. And then Control C and let us paste that particular code and calculate for Fibonacci of 35. Before I am clicking the execute button, let me write the name, time 2.45 seconds is what is being taken, and let us now execute this particular code. 0.07. What is the magic? Divide 100 times faster. What is going on? Any change in the code? Not to memorize. Memoize. Beauty. Power. What is happening? Look. Fibonacci of 20. Fibonacci of 19 plus Fibonacci of 18. And what is Fibonacci of 19? Fibonacci of 18 plus 17. And what is Fibonacci of 18?
17. So there is another.
How many times you are calculating the Fibonacci of the same number?
So it's replaced with
When you write memoirs, it will remember that. And since the functions are idempotent and referentially transparent, JIT will replace that with that particular value rather than spending time for each calculation. And will do.
But then what is the value it will replace? Because it does not know the value at that time.
Which one? I am telling first time it is calculated. Otherwise, it will calculate every time in the stack.
Okay.
First time only it will calculate. The other program, every time Fibonacci 18 will be calculated. In this slide and that side. Every time. You write down the stack and you see how many times the repetition is coming. Memoize. The ability to memorize.
So they have a separate memory for this one to manage?
Absolutely. It will cache, basically.
It will cache.
It will cache in the heap and then it will reuse that particular value.
I mean, even Java can do that.
No, you can't.
They can make it.
You can't. Tell me what is the function by which you will cache it. You will use an OS cache. I use OS cache as a separate tool for doing that. It is impossible. No way. Every time it will get calculated. Ability to memorize will tremendously change your program. So if you have that ability of memorize, if it is inbuilt into your system, just like what you have seen here, a MapReduce program, I suppose, if you write, it can also be made 100 times faster, right? Now, are you slowly getting that why Spark is 100 times faster than MapReduce? It's written in Scala. It has got memoizability. It has got referential transparency. It is idempotent. There is nowhere for Spark objects. Okay. Now, the next property is parallelizable. Again, another interesting one, right? ls cd parallelize. Should get good time on this. We are example.java. So many things. If I am finding the prime numbers, and then later I am calculating the square root of the prime numbers, and I am adding everything. Sum of the square root of the primes. Sum of the square root of the primes. Are you getting it? Sum of the square root of the primes. So first I have to calculate prime number, then I have to calculate square roots, and then I have to add it. Good. So what we are going to do? We are going to use Java 8. The beautiful features of Java 8. Streams. Entire code is in Java 8. All advanced features. Int stream.range 2 to the number. So number you are giving as a parameter. So if I give 1000 as a parameter, what does this mean? I am taking all the prime numbers or all the numbers from 2 to 1000. If I give a parameter 2000, I am taking all the numbers from 2 to 2000. Look at the functional style there. Java 8. Dot none match. What is the property of a prime number?
Can not visible.
It should not be divisible by other than itself. And no division should be there below that. So you are checking whether any number it is divisible or not, and if the particular number is not equal or not for that particular range. So you got a prime number. So you got the prime numbers. I mean, you got, if I give a number 10, it will tell me yes or no. Now, I am giving 500,000. Very big. And I want to calculate whether it is prime or not. And how will you calculate the sum of the square root of the primes? You are going to take the square root if it is a prime number, and then that prime number square root you are adding to this particular variable, and this particular variable is declared as 0. Come on, what is wrong? Already we have seen a similar program. What is wrong? What is mutating? And who is iterating? You. Right? We have seen, no?
Yes.
Yeah.
So that's a program. And rm minus rf star dot class, Java C sample.java, right? And then Java sample. You have used a mutating variable 500,000. Let the computer do some work. You have used a square root of primes, which is a mutating variable. You initialized it to double equal to 0, one big problem. You did not declare it as a final or constant or val, that means anybody can change it. And inside the code, you have iterated. It became the programmer's responsibility. You went through the complete cycle of all the numbers and you individually started adding it. The complete mutation has been used inside the code. So, little over 76, 79 seconds it will take in order to give you that result. I know it's
You find all the primes of 50,000.
500,000.
All the primes.
All the primes. Then it will calculate the square root and then it will add. That's the code. Alright. Big number. And it created the result.
1.89.
Please read the number full. What is that last two digits telling?
Oh.
After functional programming. Now, next one is what is the other one? I don't want to change this screen, so I will go to another directory and just for looking cd from fp properties and cd parallelizable, and then if I took ls, okay, there is FSample, oh sorry, FSample. Good. I am going to compile FSample.java and I am going to execute FSample and press enter. What is FSample? Look at the code. Avoid that immutability a little bit better. How? Use streams. Integer dot range closed dot boxed. I told you already that we will be using boxed. What is meant by boxed? A stream of values are getting converted into stream of integers. That's what boxed function is doing. And then filter. Is prime is a method. This is the functional style. And then map. If this particular given is number is prime, and then I am calculating the square root of it, and then for each of that I am calculating it and I am resulting that particular value. You have completely changed it to functional programming. You learned functional programming. You studied functional programming. You told that, hey, I am a good functional programming guy now, and I changed it. But you did not follow the properties of functional programming. What is that you have done again? We don't want that. We don't want that, as you asked. Now, I answer your question. You internally wrote your function. Then why you use again mutation? Exactly same result. No problem in the mathematical evaluation. So again, what is the problem? The problem is mutation. Okay, can we make it better? We will address the mutation eventually, but can we make it better? Oh yeah, we can make it better. How? I'm going to run on big data. As a big data programmer, why should I write a single thread? Can I make this one as what? Parallel, right? So let us do another code. And how much time it will take for converting everything into parallel? Java, multi-threaded program, converting it into 100 lines more. So let's write that. VI. What is that? PI, FSample.java. Huh? No more 100 lines. But it's only one word. Java 8. Entire code became. But did it become parallelized across machines or did it become parallelized within the machine on multiple threads? That's important. And if you are able to parallelize it across the cluster, what you got? Spark. Are you close now?
But what
Actually, this parallelizing is a slicing of CPU time.
Yeah, yeah.
It's not
Yeah,
only
multi-threading within a system, in the JVM, not across the JVMs. Right, so while we are doing that, let us go there and then compile Java C FSample.java and let us execute Java FSample, right?
how many threads it will take?
How can we know? Depending upon your computer. If your computer is there only 2 threads, very slow, right? If it is a Mac, it is very fast. Pala system 100 threads, 2 threads, and Selva system 100 threads. Like that. Depends upon your computing capability. We can't say how many threads.
So Java
Right.
will do an internal calculation.
Yes, internal calculation. Right. Now yours will be faster. All right, we parallelized it, and now I am going to execute it. See, I executed. Right?
The result is different. 15 seconds.
Beautiful. That's what I want you to know. What happened? Look at the values that you got. First value, second value, and third value. Wrong. You got third value wrong. Why? What happened? What happened? Anybody? What happened? Come on, what happened? What is the issue? What is the biggest issue? I will tell you, no problem at all. But there is a big mistake that is happening there when you write parallel. The variable sum of squares is now across many threads and it is shared. And which thread is updating which value it doesn't know.
It is not sequential update.
Did you now completely understand what is the problem with the mutability? What is referential transparency? Why it is very important in parallel computing? Why can't Spark be written in Java simply? And what I'm going to do now is I'm going to make it as an ultimately beautiful program. We will call it as ultimate sample.java. And in that ultimate sample.java, I answered Suendu's question as well that I called reduce initial value is 0 and call the sum on each and every value and add it to 0. System manage the mutability. And there is no sum of the squares now. And there is no problem with shared variability. You run this across 1 million machines, 100 machines, 10 machines, 20 threads, 50 threads. 50 threads plus 100 machines. Absolutely fantastic. And there is no question of getting a wrong result. Java C, ultimate sample.java, and then Java, ultimate sample, and then press enter. And then get executed it, right? This program is the initial spark of Spark. And this is why Scala is important. And this is how functional programming is written. Did you notice? It didn't take
So in the reduce, actually,
1 minute, etc. Of course, this is not doing any work, that's why it was so fast. But here, this is the idea. And now you will see that it is matching your correct results.
the reduce is actually we have to.
No? Absolutely available. And for the first time, we have written here map and reduce. And now assume that this stream is the stream of words that are coming in. And instead of this square root function, I wrote the code here, word equal to word comma 1. And then I wrote here, reduce by key. You got your map reduce in one line. So absolutely fantastic, where you use immutability, and now you are completely perfect with the idea of functional programming, where you are using immutability everywhere, and you have seen clearly what are the problems and why everybody is telling. That's the most important part of it. Why that particular thing, and why can't I change? All that questions are now cleared, right? So that's how it is there. And there is one more beautiful concept that is going to come.
Let's say if I run the same code in Scala, can I reduce time again? Because there is a memoizable property which we did not.
Absolutely, you are possible, but it's a very small amount of time. You should think about large data where you will see significant difference.
But for this one,
Yeah, it will definitely make some difference. All right, next, last property. Functional programming should support lazy evaluation, right? First, let us look at non-lazy. There is a compute function, and I intentionally made that compute function to be time intensive. How will you make it as time intensive? Just put a thread there. So compute of 5, it will just sleep, and then it will just return that number. And it is not doing anything. It is just returning that number. You can write any calculation there, but just for the example, I am just returning number. This is Scala code. In Scala, there is no need of writing return. The last line that you write inside a function is your return value. So number is the return value. So if I call compute 5, I will get 5. Compute 10, I will get 10. Start, I get the start time. What is this? System.nanotype. Java or Scala? Java. Can you write Java code inside Scala? Yes. Interoperable. If math.random is greater than 0.5 and compute of 5 is greater than 0, computed. Otherwise, skipped. Tell me, what is the output I am going to write? I am going to get when I run this particular program. Will I get computed or will I get skipped? And what are the things that you can observe from this particular program? Will the compute of 5 be calculated every time? Why? Why? It's in the code, man.
no, I did not go through.
Will that compute, it is an if condition. Will that compute 5 will be calculated every time? Answer is yes or no? It's no. Why? Do you know how AND and OR works in programming languages? AND gives you the result if this and this are true. If this is false, is there any need for executing this? Does the compiler know it? Yes. Almost all the compilers know that. They have done that much intelligence at least. Right? So let's execute it. How will you do? Scala. It is a Scala code. Non-lazy.se. It's sleeping. That's why it's taking time. 5 seconds. Oh, computed. So, if it is computed, it will calculate it because the first condition is true. Again, I want that skipped also. I think it is again getting computed. Again. Again. Hey?
Why is taking this much time? Just taking the random number.
Sleep function is in the compute, it will sleep.
Ah! Now you are happy? To make you happy only I executed it. So, compute 5 is not executed. Why? Because the math.random is less than 0.5. Compiler knows it very well. Right? Next one. Okay, how about this? Made a change. Made a change. My question is, will the compute be executed always or will compute be not executed always?
Not always.
Huh?
Not always.
Why?
Yes, still we have a random.
No, that's
Based
okay.
on your number and
Look at the change that I have done.
Temp-
Is your compute function within the AND expression, within the if, or is it outside the compute function?
outside.
So will it be executed always or will it be executed only if the AND is executed?
if the hand is
So always.
Always.
Bad. It will always be executed. It will always be executed.
Correct.
Why? Because you wrote it as an instruction. It is not part of it. Don't worry about your AND at all. Will it be executed or not?
Yes.
Yes. Irrespective of, earlier it was within that.
Yes, he was asking about not the other one.
So, I may get computed or skipped, but always what will be executed? I'll show you. Okay. Scala eager.se. Oh. Look at that. Always it is executed. No way you can get less than 5 because it's sleeping 5 seconds. Good. I don't want it to be always executed. I want it to be executed only if it is required in my previous program. Can I do that? Please look at this code again. I don't want this to be executed. I want this to be executed only if, as Bala, you said that if this value is used. Can I do that in Java? Not possible. So tell me, if I write a program to read only 10 lines of a 1 million or 1 billion lines in Java, I can't do that in Java. I have to read the entire 1 billion files, even though I need only first 10 lines. You know that?
Now, in Java, we can have a reference to a function, right?
You can have a reference to a function, but in the function, I had the same problem.
No, what I'm saying that thing, then define the preference that one, then use that one as an apply or something like that, like a consumer plus apply then everything, and use that one there.
Difficult. I don't
It
think
is
so.
difficult, but
It's very difficult.
I mean that's the way how you
Yeah.
can kind of don't.
You can make it
evaluate.
with a very much difficulty, as you told, that whether it is used or not, to find out whether it is used or not, because it's a compile time work. Please look. What is this one is called vi really lazy.sc. Scala. They learned it. They learned it. What is the word?
So what happens there?
Oh, I'm going to tell you what happens. You guess know what happens. Lazy val temp. It will remember it is lazy unless it is used. Don't execute it.
So it will be calculated at runtime actually.
Yes, absolutely. Now, if math.random is less than 5, less than 0.5, what will happen?
It won't execute.
It won't be executed. Earlier, what happened?
It will less than.
Yeah. Now, if math.random is greater than 0.5, then are you following or not, Praveen?
Yeah.
You're just looking like this.
No, I was looking at the previous comment how that is connected.
What?
You said lazy, right? Lazy.
The word lazy means that the compiler will postpone the execution of that variable until it finds that that variable is used. So, if math.random is less than 0.5, I should get a very faster result. In the earlier case, I got always 5, right? So, let us run that. And Scala really lazy dot this one. Ah, look at that. Are you clear? It didn't execute temp now, even though temp is on the top. So in the lazy evaluation, it will postpone the execution, as you can see clearly on the output.
So it can use this in the runtime, right?
Pardon?
Difference happens in the runtime.
Yeah.
But anyway, compilation has to happen anyway, no matter what.
What is done in the compilation? Compilation is having any relation with your execution?
No, I'm saying like it will not skip in a way like okay.
How will it skip compilation? Compilation is your code. Your code will be, if I write an error, I will get an error, right? Compilation is completely different from execution. Earlier, it was executing every time. You don't have a mechanism to postpone the execution.
So how the pointer it goes back again actually when it sees the next line?
It won't. It is kept at some location, and then when it is happening, at that time it will go and execute it. Go there and execute it. Compilation is over.
So for that, what sort of memory is intended?
Heap. It is all using heap, reserved areas in heap. You know, Aiden and all those kind of things.
I can use 2F.
The reason I asked,
I am not telling you can't use and all, as Raju was, right? It is very, very difficult to make sure that it is happening. My first line is more than enough, my first code, correct? But I don't want that every time that function to be hard-coded. I want to declare it as a variable. And now I can reuse it anywhere I want, rather than writing the function name directly. Correct?
Maybe I have a question. Like, generally the execution happens in the stack, right? And you have it in the like it comes actually one by one instruction, right?
Yeah.
Now you are keep going back and then using the heap. Is that
how is a final variable created? How is stacks are executed in recursion? It is following a different pattern, correct?
it has to go
It has to go through that execution pattern, but it will be using something in the heap as well.
Okay.
Final variables, etc., etc.
So you mean to say that this is made it separate?
Yes, there will be a go-to that particular instruction set which is at a separate area. Right? You do a Java P, you will see the flow.
Okay, that's right.
Yeah.
What about Scala? Scala has a Scala P.
Because Scala is compiling into a Java class, that I will tell you.
Okay.
You can see the internal code. Hope it is completely clear about what is functional programming, right? And what is Scala?
Lazy with memoizable.
Pardon?
Lazy property with
Memoizable is not in Scala. It is in Groovy. I just told you memoizable property by giving you an example from Groovy language. In Scala, that word memoizable is not there. Instead, you will use in Spark cache or persist by yourself. So can you use cache with lazy? Yes.
So that code
And no need to write lazy in Spark at all. By default, everything in Spark is. It is coming from the juice. It is coming from the juice of the experience of the programmer. What?
Just now you executed that difference, right? That was in Groovy, not in Scala.
Memoizable.
That code was in Groovy.
Groovy, yeah. I went to that fiddle site, right?
No, I was.
And then I executed it. It is all written in the help document. Right? So that's it. The video is completely there. Hear it 2